Why are all of our devices in 2016 suddenly exploding? Things look bad for Samsung right now. The company recalled the new Galaxy Note 7 last month because some of them were bursting into flame. Sent out replacements, so far so good, but now the replacement phones, the ones they said were safe, have exploded too. Now the company is stopping production of the Galaxy Note 7 entirely. The problem isn't the phone, it's the battery. Most electronics use a lithium-ion battery. Lithium is used because it's light but can store a lot of energy. But because lithium can store a lot of energy, it's in its nature to be unstable. We've already achieved almost 90% of the maximum battery life even possible from these lithium-ion batteries. But that doesn't stop people from wanting batteries that charge faster, batteries that last longer. This creates an arms race as manufacturers push the limits for really small gains. And the more you push the battery, the more likely it is to explode. We're carrying around little bombs of energy and we're pushing them too far. Lithium-ion batteries are actually pretty simple. There are two electrodes, or electrical conductors, on opposite sides. This is just like a standard battery. One electrode is positively charged, and it's called the cathode. The opposite electrode is called the anode, and it's negatively charged. During charging, lithium ions move from one side to the other. When you use the battery, the lithium moves in the opposite direction. In between are these chemicals called electrolytes, and they help the ions move more easily. They're crucial to make sure the battery works, but they're also pretty volatile. Lithium ions need to move from one side or the other, remember? So the ions have to go back and forth, but the anode and the cathode on the sides should never touch because they'll redirect energy to the electrolytes in the middle. To keep this from happening, battery makers insert separators in between. In Samsung's case, the original problem was that the separators were flawed and that the two electrodes touch. Then, all the energy being pumped in the battery goes directly to the electrolytes in the middle. It catches fire and explodes. There are other things that cause battery explosion. One way is overcharging. This is like filling a glass with too much water. It doesn't matter how slowly you go, because if you pour too much, the glass is going to overflow. Overcharging happens when too much lithium goes into one side. Luckily, most batteries are designed to automatically prevent overcharging. Then there's charging too much or too fast. This leads to something called plating. Think of it like putting change in a piggy bank. If you add one coin at a time at a steady pace, you won't have any problems. You try to drop in all your change at once, it'll pile up on the outsides where it doesn't belong. This forms these needle-like structures called dendrites that can internally short out the battery. But this can be avoided by making sure that the charger and the battery are compatible and supposed to work together. Finally, sometimes companies try to make batteries store more power by increasing voltage, which is a way of measuring force. Higher the voltage, the more power there is. So they try to pump this up by adding these other elements, like nickel, to the lithium. But again, the higher the voltage is, the more likely the electrolytes are to combine in a way that makes them catch fire. Some scientists are trying to develop a kind of electrolyte that won't burst into flames as easily. These are called ionic liquids, and they need a lot more heat to form this flammable gas. So it's a good idea. They're often much safer, but there could be challenges with battery life, and of course, they tend to be more expensive. Lithium-ion batteries are the best we have for now. And honestly, they're a good solution. They really do get the job done, as long as we don't demand more than they can safely offer.